Every model you use has a limited context window, a number. It could be 200,000, 1 million, or 10 million. And today we will try to understand what affects this number and where does this number come from. You see, most people imagine the model reading like we humans do, from left to right, linearly, but that's actually not what happens, okay? When you send a prompt, every token in it is present at the same time, all of it at once. Okay, so what does the model do with all of them at once? And here is what happens. Every token looks at every other token, and in machine learning this is called attention. And this is not a metaphor. Quite literally, for example, the token it over here will look at every other token to find tokens which matter most to understand the meaning of this token it. Okay, so I said that it looks at it, but what exactly does that mean? Well, in reality, it actually scores them. So the cat here will get a pretty high score, something like 0.82, and the will get a score pretty small, something close to 0. Then it will pull a blend weighted by these scores. Now, the famous QKV triplet that you may have seen in paper is the plumbing for this. Now, we are not doing plumbing here, but I will try to explain it in a really simplified way. Okay, so QKV. Now, Q stands for query, K stands for key, and V is the value. QKV are just vectors, lists of numbers, and every token on the prompt has Q, K, and V. So Q, the query, it represents a request formed by a token which is like meant to the other tokens and asks them like, hey, can you please help me find or enrich my meaning? The key is the list of meanings which a token can offer. For example, the cat over here can offer meanings like living thing, animal, subject, noun, and so on and so forth. And the V is the actual payload, the value, which is going to the final blend, which then is used to enrich the meaning of the requesting token. And the crazy part is that this whole process that I have just described is just one layer. On layer 2, it takes the result of layer 1 and it applies the same process on it. On layer 3, it takes the result of layer 2 and it does all this again. And it goes on and on. So, for example, a Llama 3 70B has 80 layers. A Llama 3 405B has 126 layers, which is pretty insane already, right? Now count the work. You have 10 tokens looking at 10 tokens, that's 100. You have 100 tokens looking at 100 tokens, that's 10,000. You have 1,000 tokens, that's 1 million. Now, what does that mean? Is that if you double your prompt, you are not just doubling the work that the model will do, you are quadrupling it. Okay? Now, this is where we have to talk about memory. So obviously, the model doesn't want to redo all that processing when a new token is added. So it stores the result for every token and for every layer. And this is called KV cache. And this cache sits in your GPU memory the whole time you are generating. Now we all felt this, right? You paste a big document into any chat model and there is a pretty long pause because that is when the model is doing all that heavyweight layered QKV processing. And obviously you need a good hardware, to compute all that and to store all that somewhere. That's why the context window is dependent on the hardware and it expands only when the hardware evolves. Okay, so everything that we have discussed here today is a part of a toolbox called Transformer. Now this toolbox has other tools in it, such as the feed-forward network. But that's a topic for another video. For this one, thank you for watching and see you next time.